Hopefully, this will give you a clue how these things can be diagnosed. And now we can start and discuss, okay, the homework. All right. Who is going to start? Who has 101?
Sorry, my voice is, it was my
I
phone.
cannot hear you.
Oh, really?
Okay.
Uh,
You want to share your screen?
can you hear me or not?
Yes, I can hear you very barely,
Uh,
very.
okay. I didn't work a lot on mine, so I don't think it's really useful to share my screen.
So you don't want to share your screen.
But I didn't work a lot, so it's not
Okay.
really useful.
Okay. Now
Uh,
let's go and I'm sharing this one, as you see.
yeah.
Now let's evaluate it. Which is the first things that we have to do?
The rhythmicity,
Okay. Is it rhythmic?
it is.
Okay. Good. So
Uh,
it's rhythmic. Next one, heart rate.
there's 1 QRS every 3 squares, so it's approximately 100 BPM.
A little bit less because it's more than
Yeah,
three squares. Fine. Okay. So it's normal. Okay.
yeah.
Next one, we said that the
The
axis. Okay. You can
axis.
say the axis. Okay. One
So
is
the one is almost equiphasic, but it's positive, I'd
that's
say.
positive. AVF is
AVF
positive.
also is positive. So it's a normal axis between 0 and 19.
Okay.
And um, I said that AVL is negative, so it's between 60 and 19.
60 and
90.
Y.
Because AVL is negative.
Okay, okay. All right. So it's between 60 and 90. Very good. Okay, good. All right. Next one. Is this a
Um,
sinus rhythm?
yes, every P wave gets conducted. Also
Okay.
occurs after every
The
P wave.
PP interval constant, the P positive in
Yeah.
lead number two, negative in AVR. That's a sinus rhythm. Okay. Next one. Okay, you should know the morphology of the P wave. Half wide is this one is less than zero point 0.1 second, and the amplitude is less than 2.15 millivolt. Okay, this is why you have to know this one, but of course the ECG gadget is going to write it. Now let's evaluate
The
the PR
PR
distance.
interval, yeah, and the PR interval is big. Like I calculated something like 0.34 seconds, I think, something like that.
Okay, so
So
it's
it's too low.
almost zero point 0.3, almost zero point 0.3
Yeah,
seconds. You can see that
so
doesn't matter.
it's
So
more
what is
than
your
zero point
diagnosis?
0.2. So for me, it's AV block, first degree AV block.
First degree of AV block. Good, very good. Okay, good. Let's go on. 102. Who has 102? Is not here. Okay. Good. It's very similarly rhythmic. Yes, it's rhythmic. The rate is slow. One, two, three, four. Five, almost five. So it's close to 60. Maybe it's a 65 or 62. Doesn't matter. Good. Do we have P wave? Yes, we do have P waves. Again, however, the PR distance is very long. Axis one positive. AVF is positive, so it's normal. If you are looking at equiphasic one is lead number three, so it has to be around 30 degrees. Okay, good. All right, 103.
Yes,
Okay. Do you want to share your screen or I should keep sharing?
I will share my screen.
Okay, good. I'm so happy. Your turn.
But how can I share my screen?
Yes, a share button. Okay, that's a green share button. Punch it and choose the entire screen. Hmm? Oh, okay. No, yeah, it's coming. That's great. Okay, good. All right. Magnify a little bit if you could. Yes, good. Very good. No, tell me your story. That's very nicely prepared, ECG.
So first, if I check the rhythm,
Uh-huh.
QRS is preceded by P wave, and P wave is positive in read 2 and
Mm-hmm.
negative in here, so it is sinus rhythm. And if I check the RR interval, it is about 3.5 beat square, so
Mm-hmm.
the heartbeat is about 85 BPM, which is
Mm-hmm.
lower. But I think the rhythm is irregular because after the first cycle, there's P wave without following QRS.
Uh-huh.
So I
You
think,
should point it if you could, but I can make some notes if you let it me. For example, this one, okay, this P is not followed by QRS, yes?
yeah.
Okay,
So I think it is secondary gravity block.
okay.
And if I check the PR interval, at first cycle, it is about 0.28 seconds, but after the non-conductive P wave, the PR interval is about 0.2 seconds and then 0.24 seconds, so it is getting longer, I
Mm-hmm.
think.
Mm-hmm. Mm-hmm.
So I think it is Mobitz type 1 secondary gravity block,
Okay,
but
Mobius type 1AB, very good. Okay. However, when you diagnose a Mobius type 1 AV block, the best one, find the P is not conducted. Okay, this P is not conducted. Yes, this is a drop P. Next one, you have to compare the length of the PR. This is the last conducted, okay, and compare to the first conducted. All right. If they are equal, Mobis type 2. If the last one is longer than the first one, Mobis type 1. Because if you do have a relatively more bit that is conducted, this increase is so small that relatively you miss this elongation. But the last one, longer than the first one. This is the definition of Mobis type 1. Okay? Compare the last one to the first one.
yes.
Okay, good. Very good. Anything else? Have you said anything about the axis?
Yeah, the axis, the lead one and AVF are both positive, so it is between 0 and plus 90 degrees. And the lead one is most equiphasic, and
Mm-hmm.
the AVF is positive, so I think it's plus 90 degrees.
Okay, good. Very good. Okay, good. Next one is 104. Yes. Who has 104? Okay. Maybe I have to find. Okay, 104. There is no 104. 105.
Yes, good
Zoe.
morning.
Yes, you are going to share your screen for sure.
Yes. I will, I
And
will.
you have two.
Yes, I do. Let me see
Yes,
if I can.
I gave you because
Okay.
the last time it was too easy.
Can you oh,
Not yet.
I'm on a different computer, so I have to
Okay, I'm going to share it,
uh,
okay?
okay. It's a shame because I annotated it nicely, but anyways.
Okay, you have to log out and log back. That's the problem. Okay, so 104, okay?
105.
No, 105. I'm sorry.
Yep,
I'm sorry.
yep, yep, yep.
105, okay? All right.
1 second. I just have to. Okay. So I started by looking at the rhythmicity and whether it originates from the sinus node. So we
Mm-hmm.
can see that there's P waves before every QRS. They're also positive in lead number 2 and negative in AVR. So we know that it's a sinus rhythm. It is around 60 beats per minute. That's what I calculated. It's like
Mm-hmm.
5.5, sometimes 6 squares.
Mhm.
But it is noteworthy that this is not the same all throughout, which I will talk about a little bit later. But first, looking at the intervals, they are normal and there's a 1-to-1 conduction ratio. For the axis, lead number 1 and AVF are both positive, so we have a normal axis, which is around, I think, 50 degrees because lead 2 is more positive. For the anomalies, I noticed a ST elevation in lead 2.
Don't go to rest elevation. You mentioned that you do see a one-to-one conduction. I have a doubt about it. First of all, that's a P wave. Okay,
Yeah.
that's a P wave here. That's a P wave. That's a P wave. Here you can see immediately that this piece is not conducted. Yes? This is a not conducted. Conducted, not conducted. So again, you do see some unconducted bits. And this makes it arrhythmic. All right.
Okay.
Inside, see, inside the T wave, you should, it's a little notch, little notch.
Okay.
That could be a P wave. Okay. So it is not one-to-one. We are not going to the ST elevation yet. When we're discussing the ischemia, yes, but we do have. So what does it mean? It's meaning that not every P conducted. Okay. Here, for example, it looks like this every second is conducted. However, again, every second is conducted. Every second is conducted. Here, every second is conducted. Every second is conducted. Every second is conducted. But, okay, so
Um, I'm not sure because I didn't notice this. I thought it was an ST elevation, which is why I was
that's
unsure.
okay. That's okay. That's ST elevation is fine. That's ST elevation is fine. We are not going to say something about this ST elevation. One thing, however, here, look at this part.
Yeah.
Look at this part. Here, not every second is conducted because this conducted, this is not conducted, this conducted. So again, that looks like that's a second degree AV block. And if you're comparing the last conducted PR to the first conducted PR, that is not the same. So the last one is longer than the first one, okay? Meaning that we do have Mobis type 1 AV block, okay?
Okay.
And of course, we do see an ST elevation and everything, but we are talking about later, not today. Okay.
Okay.
It's like a sitting rabbit or one thing that's fine, but that's an MI for sure. That ST elevation and STEMI and is inferior. It's okay, but next time or maybe later on, because first I think we have to practice a little bit. But this is Mobis type 1 AV block. That's period. Okay. Now, what I think let's move on first. And meanwhile, what you can do if you do have your computer ready, please let the computer using the file or sharing the file after log out and log back immediately. Okay. And the next time you can share your presentation.
Okay.
All right. Let's move on. Who has this 106? Wait a minute. I have to look at what I gave. 107. Okay. Mayuto, do you want to share your screen? He's not here. Hussein,
Hello.
are you going to share your screen?
Sorry, could you share your screen?
Okay. Yes, but I have to know. This one is 108. Okay. 108. Yes, I'm sharing my screen. It's your turn.
Okay, so first I can see that it's arrhythmic, and
Mm-hmm.
then I was able to calculate the heart rate using lead 2. I
Mm-hmm.
calculated the heart rate by counting the number of beats in the first 3 seconds, and it was 160 beats per minute. So it's a form of tachycardia. And to calculate the
You
axis,
are talking about, let's say, the PP interval, yes?
yes.
Okay.
And
Because
then
it's bradycardic, but the PP is faster, okay?
yeah, and then to calculate the axis, both lead 1 and AVF are positive, so it's between 0 to 90 degrees, so normal
I
axis.
do not think so. One is positive, that's fine. But AVF is?
Oh, it's
Negative.
more negative. Oh,
And lead number 2, negative.
negative.
What does it mean?
It's slight left deviation.
Pathologic, not slightly, because if I drawing this hexaxial system, this is what you have to have by heart. Okay, this is lead number 2. This is AVL. Okay, this is minus 30. Okay, minus 30. So that meaning that you are somewhere here. Okay, that's an extreme.
Extreme deviation. Okay.
Yes, but AVR is positive, so it means that we do have, that's a minus 60. So this is between minus 60 and minus 90.
Minus 90.
So that's an extreme left deviation. And what does it mean when we do have an extreme left deviation? Now we know it.
The left
Anterior
anterior
hemiblock.
hemiblock.
See, that's a hemiblock. Immediately you can judge what this extreme left deviation means because the QRS is narrow, all right? This looks like narrow, and we have this kind of problem. Okay, now look at now the P waves. So we do have more P's, but some is conducted because the PR interval is constant whenever you do have conducted P's, okay? That's meaning there are more than one unconducted P's between two conducted one. That means that's a high degree AV block. And as you see, how many? 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. So this means 4, 2, 1 AV block. That's a high degree AV block with the left anterior hemiblock. Now, what do you say about it? Okay, good. Now, let's move on. Who is the next one? Okay, I have to change it because I do not know by heart. 109. Utano? Okay. Next one in the row is 111. Bara.
Yes.
Are you going to share your screen?
No.
No. Oh boy. Okay, 111. I have to find it. 100 and okay, sharing. And after we go back to the 134, don't worry. 111. Okay. That's a simple one. Go on.
Yeah. So it is rhythmic. And the heart rate is 75 because there's
Mhm.
like four squares between the QRS, the like RRs. And the axis is normal.
Mhm.
There is in lead 2, there is like B waves, and the AVR is negative, so the sinus is activated.
Mhm.
But like the BR interval is like longer than 0.20 seconds.
Mhm.
So it's a first degree AV block.
Okay, that's it. This is what we can say. Nothing else, only first degree AV block. Okay, good. All right. Good. And the next one, not that one. Okay, the next one is 113. Yonushka. Are you here? 114. Lynn? Okay, 119. Eva? Oh boy. 122.
Sorry, I'm here. I have 114.
114. Okay, are you going to share your
Yes.
screen?
I can try if you give me 1
Try,
second.
try, try. Please try, I try.
It says open system settings, so do I have the same problem as the others?
Okay,
is it
I will share it. Okay, I will share it, but you have to do the same, uh, and the next time you can use it.
I can try
100,
and send the
but you have
I
to
can
log
try
out
and
and
send the
log back.
file in the chat. Yeah, but I have it on
No,
my
no, no, no.
desktop
Okay,
if you can
say it,
open it.
say it. Okay, this is 114, yes?
Uh, yes,
Okay,
I
now
think
tell me the
so.
story.
So I wrote that it's rhythmic and
Mm-hmm,
the heart rate is about 40 beats per minute. I measured 6 seconds and there's 4 hours, so it's bradycardia.
mm-hmm,
The lead 2 is positive and lead 3 is positive. So between 60 and 120, I think.
yes.
And then lead 1 is mostly negative. So it should be closer to 120.
Mm-hmm, okay.
And then the
Or
P
if you are
waves
looking, wait,
are a
wait a
bit
minute, wait,
strange.
wait,
They're a
wait,
bit
wait, wait,
changing.
wait, 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 wait. As you see here, the in lead number 1, the QR shape is changing. See? This is why, because the breathing and diaphragm, okay? So this is a little bit
Yes.
negative. So your yard is close to 100, so 90, 100. This is what we have. Okay, go on. Now you can go on. All right?
I was thinking about the P waves in lead 2 because they
Okay.
keep changing like their shape. So maybe a multifocal atrial beat formation. Um, but I'm not sure. And then there's no Q or S wave in the QRS complex. So I don't know if that's because the depolarization vector of the wave is going straight towards the electrode or if there is some other issue.
No, it's
And then
not
I
an odd
think I have
ratio. It's not an odd
it's just,
ratio. It looks like, again, every second beat is conducted in a P wave, yes?
yeah, I thought maybe an AV block like the same as Zoe.
Yes, that's it. AV
Okay,
block. 2
but
to 1 AV block.
why is there no Q and S wave? Is that because of that?
No, no, no. Here, this is unconducted. This P is unconducted. It's not conducted. So relatively, the AV is blocked completely. Paf, here. But the next revolution is goes through.
Okay.
Here is not conducted. Here is conducted. Not conducted. Conducted. This is 2 to 1 AV block. Okay.
Okay.
This is how the 2 to 1 AV block works. Okay. Good. All right. Let's see. Okay, stop sharing. And again, I have to find it. Eva, are you here? Ah, somebody shared the screen. This is Lily, Lily, Lily. Okay, now you could share your screen, but you already finished it, yes?
Yeah, I don't know what I clicked on, but it seems like it worked.
Yes, it's working. It's fine. Next time you can do it very nicely. Okay, good. All right, now the next one is Eva, 119. No. Muniba? No. Okay, 123. 126. Who has any ECG left? Tell me.
I'm here. Hello.
Okay, okay. I have to move it. Who is hello?
Uh,
Okay, Shri. Yes, 127. Okay. Are you going to share your screen?
yeah, I can share my screen.
Good, do it. 127. Okay, 127.
Can you see the screen?
Yes.
Okay. I'm not okay. So it looks rhythmic.
Okay.
And the heart rate I measured was 60 beats per minute.
Mm-hmm.
And the axis is also normal because it's positive in lead one, and I think like equiphasic in AVF.
Mm-hmm.
And it's a sinus rhythm. Um, I think it's a right bundle branch block because I looked at the V1 and it had like an M complex and
Yes, but first, because we started, okay, first, we do have P wave, yes. The PR interval constant, yes. QRS width is wide or not. You have to look at the all leads, and you found in V1 that the QRS is wide, yes?
Mhm.
Good. So that means some kind of intraventricular block we have. Okay, now what you have to do, look at the right side, look at V1 and V6.
Yes.
And because you do see this RSR pattern in V1, this
Yeah.
is what as the right bundle branch block. Yes?
Yes.
Good. Axis?
The axis for like the electrical axis, I think it's the normal one, normal axis.
Okay, you are not thinking that's a normal axis. And AVF is all about equiphysics, so it's zero. That's normal. All right? That's it. So we do have a complete right bundle branch block. Yes?
Yeah, we do. Yep.
Oh, that's it. Good. Very good. Okay, now. All right, so that was 127. Anybody? Mobina or
Hello, hi.
hi? Are you going to share your screen?
No, can you share your screen, please?
No, I'm not going. I'm not. Okay.
I said
120,
130.
128, yes?
No, 130.
130, yes. Okay, good.
Okay, so it's rhythmic,
Mm-hmm.
and I calculated the heart rate on lead one from the RR distance. There were 4 squares, so
Okay, rhythmic. Now, let's see uh, again. Don't look at the top part. Look at the bottom when we do have the rhythmic strips. Okay, here.
mm-hmm.
This is rhythmic.
Oh yeah, there's a bigger distance, yeah.
So it's not
It's not
rhythmic.
rhythmic.
Okay. The average heart rate is around,
Like 75.
okay, around the normal. Good. P wave.
There is a P wave,
Where?
like
Tell me.
not on V5, but
Okay. Here, for example, some kind of wave that you do see here, yes, in V1.
yeah.
But this is not a normal sinus P wave for sure. And the rate is very fast. So this is arrhythmia, no P wave or very fast P wave, more than 350. This is
AV block. Oh, flutter waves.
atrial fibrillation, not flutter. The flutter is less than 300, and that's faster.
Ah,
And arrhythmic, this is arrhythmic. This is why arrhythmia, no P wave, atrial fibrillation. If somebody wakes you up at midnight, you have to say immediately atrial fibrillation, and after you can judge what the other wants. Okay, atrial fibrillation. Good. Now, so you don't need to talk about the P wave or the PR interval. Great. You have to talk about the QRS complex.
the QX complex is like wide, like wider than.
So what do you think? Why?
I have no idea.
Okay, guess. Why the QRS can be wide? First of all, atrial fibrillation is a supraventricular rhythm or ventricular rhythm. Where the impulse form in atrial fibrillation? In the
It's
atrium.
yeah.
In the atrium. All right. So every charge made by the atrium. So, and this is why it's arrhythmic because randomly goes through the AV junction. Fine. So the ventricle is the ventricle reached by the normal conducting pathways. So why the QRS is wide? because you do have intraventricular conduction abnormalities. Yes? So inside the ventricle, we do have some block. What we have to do? Look at V1 and look at, doesn't matter, lead number 1 is the left. So the right ventricle and the left ventricle. What do you see in lead number 1? QS complex, yes? Very wide S wave. What do you see on the left side? Very wide R wave. So, what does it mean? That's a left bundle branch block. Okay, good. What about the axis?
The axis, lead 1 is positive, and AVF is negative, and lead 2 is also negative. So I think it's left axis deviation.
Pathological left axis
It's just
deviation. Okay, but because you do have a left bundle branch block, that meaning we do have an anterior and posterior together, itself can cause pathological left deviation. Okay?
yeah.
So when we do have a left bundle branch block, can you explain why we do have an extreme left deviation? If we do not have wide QRS and we do have an extreme left deviation, left anterior hemiblock. Okay?
Okay.
All right. Good. Next one. That was 130. Yes, 130. And the next one, who is here? Victoria, you are here.
Yeah, I'm here.
133.
Yeah, I can try to share.
Okay, try it.
Share. Uh, maybe it works.
It's coming
I'm
up.
not,
Yes.
yeah,
Good.
I'm not very sure about it, but I tried.
What did I say the last time? Never ever say that I am not sure, I'm not 100% positive when you are taking any kind of exam.
Mm-hmm.
Yes.
Yeah.
If you want to sell yourself, you have to sell yourself. Okay.
Yeah.
Yeah. I cook something for you, but it's not so good. I don't think that it will tasty. And I like you, but I don't know exactly I do. What would you
Yeah.
say?
Yeah.
Okay. Yeah.
But I did find out that it's I don't know if I'm like very I cannot see like how I'm sharing the screen. But I think so the heart rate is around 100 beats per minute. I
Mm-hmm.
counted like almost like 3 boxes. So
Mm-hmm.
it's slightly tachycardic. And then for me it's kind of rhythmic. I don't see
Mm-hmm.
any like very long or very short
Okay.
periods between the
Joystick. I can
yeah.
accept it. Okay.
And then for the axis, lead 1 is positive and also lead 2 mostly. Or like maybe it's equiphasic. And the AVF is negative. So I think it might be like kind of normal, but slightly left axis deviation. But
Okay. What do you mean slight? Lead number 2 is negative. For sure, you have a pathological left deviation.
okay, yeah. Okay, so left deviation. But
So you
the
have to summarize. You have to summarize the positivity and negativity in the QRS. If the negativity is deeper than the positivity, that's negative. Okay.
yeah.
Okay. Go on. So that's a
Um,
pathological left deviation so far. What else?
okay. I saw the notches in the AVR, like the M1,
Is
but
the QRS is wider than normal?
I
Get closer.
in
In V1,
yeah,
whenever, or lead number 1, doesn't matter.
mm, maybe in V1.
Yes, it's wide. It's wide. Yes, it's wide. What does it mean?
Bundle branch block.
We do have intraventricular block. Okay, Now you have to look at V1 and V6 or lead number 1 on the left side. You do see a nudged R wave in V1 and a slurred deep S wave in V6, with lead number 1. What
Yeah.
does it mean?
Was it
Yes.
left axis?
No.
Left bundle branch.
No. Whenever you do see the R complex, the block is there. Here you do see the R complex in V1, so on the right side. So you
Okay.
do have a right bundle branch block, yes? Right bundle branch block. And you do see a extreme left deviation. That means bifascicular block, because you do have a right bundle branch block and left anterior hemi block. This means bifascicular block. Okay?
Yeah.
Yeah. Okay. All right. Next one, 134. Don Chan. Are you here? No. 135. Antoine. 143.
Hello
Zoe.
again.
Hi.
I will try and share it now. Hopefully it works.
Okay, do it.
Does it work?
It's working.
Okay. So is this zoomed in enough?
Yes.
Okay. So I started with the basic things. So P waves are preceding the QRS complexes, although it's very small in lead number 1, but it is, I think, there. It is positive in lead number 2 and negative in AVR. So we have a sinus rhythm. However, the heart rate is around 100 beats per minute. So we have sinus tachycardia. For the axis, lead number 1 and ABF are both positive, so the axis is normal. However, I think it's more close to 30 or closer to 0 because lead number 1 is more positive. And yeah, this is once again the anomalies. So I noticed that the QRS was slightly prolonged. It was around 100 and 140 milliseconds. So I think that indicates some kind of intraventricular block. And I looked at V1 and V6, and in V1, I did notice the RSR kind of shape.
No. That's a deep S wave that you do see. This is, I don't think that's a QS complex. That's a QS complex. Okay, that's a QS complex. But you haven't said anything about the P wave.
The P wave. It's not really there. I mean,
yes, there are. For example, here in lead number 2, you can see it.
Yeah.
And here, lead number 3, you can see it. Yes? And that's it. And if you go here, you can see it because that's a P wave, yes? And right behind of the P. And here is a P wave, yes? And here is a P, yes? And right after the P, the QRS starting with a notch.
Okay.
A delta wave. So this is a
it was a pre-excitation syndrome.
WPW syndrome, exactly. WPW syndrome. Now, this is not a right bundle branch block for sure because you had to have a wide QRS inside in V1 if you had a right bundle branch block. This looks like as a left bundle branch block. And what did we say about it? This is the type B.
Okay.
So WPW type B. Okay.
Okay.
I think the next time we will practice and everybody should have the all ECG tracing, including their impulse formation and conduction. So great. Okay. All right. Okay, so I will stop it. Okay.